Hi there. Let me take a few minutes and discuss some things that will be helpful for you on the linear regression study guide. So first of all, if we go back and take a look at the scatter plot of the data, so remember that the explanatory variable is pre-calculus homework average. The response variable is pre-calculus exam scores for these girls that were in my pre-calculus class a few years ago. So in question number 1, in terms of review here, the direction is positive, the form is reasonably linear, and the strength is moderately strong. So continuing then, the goal of this study guide is to actually build a linear model that we can use to represent these data. And that model in question number 2 would look like this. The estimated pre-calculus exam score can be found by taking negative 1.69 and adding to that 0.96 times the pre-calculus homework average. So there is another way to write this. So the pre-calculus homework average is the input, or the x value. The estimated PC exam score, that is the output, or the y value. So you could also write it like this. This would also be a perfectly reasonable way to write this model, but it's very important to recognize and communicate that the output is estimated or predicted. In order to communicate that using x and y, you need to put a hat on top of the y. That means that we have an estimated y value. And if you want to use x and y, you also have to define them. So in this case, x is homework average, and the y values are exam scores. So interpreting then the value of the slope and the y-intercept, that's a critical part of this unit. So the slope is the most important because it shows us the connection between the changes in the explanatory and the response variables. So let's interpret that first. So I assume from Algebra 1 you'll recognize this. The slope is the change in y compared to the change in x, although in this case y is the response variable, x is the explanatory variable. You can remember that because it has x in it. So for the context of this question, the response variable is exam score. The explanatory variable is homework average. So of course the slope is in the form 0.96. It's not in the form of a fraction, so I can just write that 0.96 over 1. And I wrote it specifically as positive 1 so that we can talk about the relationship here. That positive 1 refers to an increase of 1 unit in homework average. So that would be an additional percentage point for someone's homework average. That is connected to a 0.96 point increase in exam score, and that's what we mean by interpreting the slope. So in question number 3, for every additional percentage point of homework average in pre-calculus, a girl's estimated exam score increases by 0.96 points. So again, we're looking at the connection between the explanatory and response variable. So going to the back side then, I will offer that for question number 4, it is very often that the intercept, in this case the negative 1.69, really does not have a good interpretation. So I'm going to write it over here. Here's the model from the front. Our predicted y value, or our predicted exam score, was negative 1.69 plus 0.96 times x. That x value would be our homework average. So understand, to find the value of the intercept, that's the same as making x 0. So if the homework average is 0, that term disappears, and the predicted exam score then is negative 1.69. which the truth is a negative exam score doesn't make a whole lot of sense. So for a girl, a pre-calculus homework average of x equals 0 corresponds to an estimated exam score of negative 1.69 points. Don't worry if the interpretation of the intercept doesn't make a whole lot of sense. It's the interpretation of the slope that we really care about. And once we have our equation, we can make predictions with that equation, and that's what questions 5 and 6 are about. So in question number 5, a homework average of 75 is specified. So that's an x value. And we're trying to find the predicted y value that would be connected to it. So to find that, all we have to do is take the 75 and substitute it into x's place and find the y value that goes with it. So we can do that on the home screen with no problem. So the intercept is negative 1.69 plus 0.96 times the 75, which is the homework average that we're making a prediction for. 70.3 then would be the estimated exam score. So that is also the predicted y value. Here we go. That gives us an ordered pair. And in particular, that is an ordered pair that is on the regression line. You can do a similar analysis. The 85 for homework average, that will correspond to an exam score of 79.9. So both of these ordered pairs in questions 5 and 6, both of them fall exactly on the regression line. So if you are interested in plotting the regression line, you can just plot these 2 points and draw the line through them, and that's what question 7 is about. So notice I gave you the scale here. So the x scale was 5 units. The y scale is 10 units on the graph that I gave you. So you should always label your axes. So the explanatory variable is homework average. The response variable is exam score. And I'll label a few more points. So with a scale of 5, we have 70, here's 75, here's 80, here's 85, and 90. So the y scale increases in increments of 10. So we have 50, 60, 70, 80. There we go. So literally to plot the 2 points, let's not work too hard. From number 5, it was 75 and 70.3. So here's an x value of 75, and 70.3 for a y value would be right about there. So I know that point has to be on the regression line. Similarly, 85 and 79.9 looks like it would be just about there. Those 2 points have to be on the regression line. They relate x values with estimated y values. So if I want to draw the regression line, I can just connect these 2 points with a straight line. I'll use my Westfield Rocks booster card there for a straight edge. There's the regression line. That's one way to do it. Of course, if you want to do it in your calculator, you could simply enter the expression into the y equals menu. So into the y equals menu, we will put the model, the negative 1.69 plus the 0.96 times x. And right here, here is the x button right here. We can hit graph, and you'll see exactly the same linear model that we drew by hand in number 7. So you can create a linear model if you have the data by using this linear regression command on the graphing calculator. Something else I would want you to recognize, though, you can calculate a linear model by using the correlation and then using the summary statistics for center and spread for both the explanatory and response variable. Let's do that briefly. That's what question number 9 was getting you set up to do. So the correlation here, the correlation that we have, and let's see right here. Here we go. It's 0.75. Running the the 2 variable statistics command, the mean of x is 82.3. The standard deviation of x was 11.9. So those describe that is the center and the spread for the homework averages. And then for the y values, the mean of y, 77.3. The standard deviation of y, 15.2, center and spread of the exam scores. So, using these data, here's another way to calculate the slope. So the slope can be found by taking the correlation times the standard deviation of y divided by the standard deviation of x. So this isn't a formula you have to memorize. This would be given to you on a quiz or a test or even on the AP exam. But notice it makes some sense because the standard deviation of y is in the numerator, just like the change of y is in the numerator for the slope. And the denominator has the standard deviation of x, just where we expect the change in x to go. So let's substitute in our values here. So the correlation was 0.75. The standard deviation of y is 15.2, and the standard deviation of x was 11.9. There we go. If we put that in the home screen, We should get an answer that looks pretty familiar, so let's go do that. So on the home screen, the correlation, 0.75, times the standard deviation of y, 15.2, divided by the standard deviation of x, 11.9. And there we go. Again, 0.96. There's our slope. So this can be a handy expression when all you have are the correlation and summary statistics. If you want to actually find the slope, you don't need the data to find the slope. And then finally, to find the intercept, the y-intercept, that can be found by taking the mean of y and subtracting the slope times the mean of x. So we'll substitute those values in. The mean of y is 77.3 minus the slope of 0.96 times the mean of x. The mean of x is 82.3. Again, we'll go to the home screen and do that calculation here. So 77.3, mean of y, minus the slope, 0.96, times the mean of x, 82.3. There we go. Here is our estimate for the y-intercept, negative 1.71. Notice we're off by a couple of hundredths, and again, that's rounding error. We had to round so many values to calculate the y-intercept. We had to round when we created the slope, we rounded the mean, we rounded both of the means for x and y. So negative 1.71 looks like what we get here. And again, that's really close. I'm not worried about the rounding error, in fact. So that's another way. Those are two ways to build that model. And essentially, the reason that this works for calculating the y-intercept is because of one simple fact, which can be convenient. The mean of x and the mean of y actually create an ordered pair that is always on the regression line. So one last little clever fact to know that might be helpful. This point, the mean of x, comma, the mean of y, is on the regression line. X bar, comma, y bar is a point that is on the regression line, and that's actually the way that we built this expression for the y-intercept. And you can confirm this actually pretty quickly if you go to the home screen. So take a look. We'll clear the home screen here. So if you take, let's see here, the negative 1.69 plus the slope of 0.96 times the mean of x, so the mean of x was 82.3. If we do that, the output that we get is indeed the mean of y. It's the 77.3. So just like we said, the mean of x and mean of y actually create an ordered pair that indeed fits the regression equation. That is another handy fact to know. Here, I'll list it one last time. Mean of x and mean of y is on the regression line, and that's where this expression came to calculate the y-intercept. So hope this has been helpful. Take care.